In 2024, Ford Motors cut back production of their F-150 Lightning, the electric version of their popular pickup truck. Sales on the Lightning had tanked, in part because it cost more than its gas-powered counterpart. This isn't just a problem for Ford. The average price of a new EV in the US is about $55,000, making electric cars a hard sell for most US consumers at a time when EV adoption is critical for our climate goals. Roughly 40% of the cost to produce an electric vehicle is in the battery. In 2023, Ford was looking at sites in Virginia or Michigan for a new battery plant that could help lower its costs. But there's a catch. The battery technology it would use is from a company based in Fujian Province, China. That company is CATL, the largest battery maker in the world. Virginia's governor decided to kill the battery plant proposal in his state because of its links to China, citing influence, if not control, by the Chinese Communist Party. This put Ford's CEO on the defense, insisting the plant would be a wholly owned subsidiary of Ford, and left the company to look elsewhere for a site. This battery plant got caught up in a broader trade war between the US and China. In reaction to the extraordinary rise of China's electric vehicle market, China makes up over half of all EV sales globally, and in just a few short years has brought slick and affordable electric cars to the market. Key to this rise is the electric vehicle battery, an area where China has come to dominate the global market. So how did Chinese companies create the world's leading EV battery? And can US automakers make an affordable electric car without it? The first major reason for China's dominance in EV battery development is a huge amount of government support. Roughly 20 years ago, China was on track to become the world's largest importer of oil, so electrifying its car fleet would help it become more energy independent. Additionally, there was a growing air pollution problem in China's cities due to car emissions. The head of the Ministry of Science and Technology, a big believer in EVs, sensed that Chinese companies would struggle to compete in internal combustion engine technology. This led to a package of policies supporting what the Chinese government defined as new energy vehicles. Companies making EVs received subsidies whenever they sold a car, along with cheap land leases and loans from state-owned banks. From 2009 to 2022, the Chinese government gave out $29 billion in subsidies, research spending, and tax breaks to the EV industry. Local governments also supported EV adoption by contracting Chinese companies to electrify bus and taxi fleets. For example, Shenzhen's fleet of 16,000 buses was electrified by BYD before it became the world's largest EV company. Consumers also received generous subsidies and other benefits like discounts on charging, favorable parking, and traffic congestion policies. EVs even had different colored license plates, making them easily recognizable and desirable. In the early days, the battery technology wasn't very good, so the Chinese government introduced stricter battery standards, qualifying only those that met certain density levels for credits. As consumer EV sales in China exploded, the government protected its battery industry by requiring foreign car companies like GM and Tesla to use Chinese-made batteries to qualify for consumer subsidies. Though consumer subsidies were phased out in 2022, the demand had been created. In 2024, over half of new car sales in China were electric, marking a significant milestone in consumer preference for EVs over gas cars. The second way Chinese battery companies became dominant is through control of the supply chain for battery components. The typical EV battery is a lithium-ion battery composed of four main components: the cathode, the anode, the electrolyte solution, and a separator. The cathode usually contains nickel, cobalt, and manganese. The anode uses graphite, and the electrolyte is made up of mostly lithium salts. Chinese companies acquired ownership stakes in mines worldwide, ensuring control over the production and pricing of these minerals. More importantly, China refines a vast majority of these minerals, a process that is polluting and thus avoided by developed countries. Chinese plants also manufacture the majority of the four components and assemble them into battery cells. Historically, the US was never a player in lithium-ion battery manufacturing. This was dominated by Japan and Korea until China superseded both. China's control of the battery supply chain is so comprehensive that after the Biden administration passed a rule requiring no more than half of a battery's components or minerals to be Chinese-sourced to qualify for tax credits, only an estimated 20% of EV models qualified. With their market dominance, Chinese companies have led the world in battery innovation. In recent years, they developed lithium iron phosphate, LFP batteries that avoid using expensive minerals like nickel and cobalt. In 2023, KTL announced an LFP battery capable of powering a car for 370 miles on a 10-minute charge, and BYD developed a version called the Blade battery, designed to cram more cells into the same space. Today, LFP batteries are a growing share of all EV batteries, and nearly all of them are manufactured in China. However, this is changing. CATL has built battery plants in Germany and plans one in Hungary for the European auto market. Ford found a home for its CATL battery plant in Marshall, Michigan, despite a U.S. House investigation. If it proceeds, it will be the first LFP plant in the U.S. All these factors have made Chinese EV batteries virtually unavoidable in the global transition to electric vehicles. Was there a viable alternative? No, there wasn't. LFP technology is well developed, and the battery business is global with no viable alternatives. Concerns remain about whether China's government's support of the EV industry amounts to unfair competition, along with human rights and environmental issues in China's battery supply chain. The U.S. is investing in building its own battery industry, with Bloomberg estimating it would cost $82 billion to meet domestic demand by 2030. This may be possible in the future, but it doesn't help now when we desperately need to transition to electric vehicles and U.S. automakers struggle to offer affordable options. For now, we must decide whether our desire to distance ourselves from China outweighs our goal of going electric.